Determine all of the pairs of integers xy such that x cubed plus y cubed equals x plus y quantity squared. So the first thing I'm going to do is I'm going to factor x cubed plus y cubed. So that's going to be x plus y, x squared minus xy plus y squared. Again, this is SOAPs where this variable is same, opposite, and then always positive. And this is equal to x plus y quantity squared. Okay, so it's important to note that we have two cases here. One is where x plus y equals 0, in which case this is pretty obvious. The values for x and y can just be k and minus k, where k is some integer. Okay, that really doesn't mean much. And then we have the other case where x plus y is not equal to 0. And that's really what we're going to be looking to solve here. So to do this, I'm going to start off by dividing by x plus y on both sides. So we are now left with x squared minus xy plus y squared equals x plus y. Now, this over here would be a lot easier to factor if I had 2xy. So I'm just going to multiply everything by 2. So I have 2x squared minus 2xy plus 2y squared equals 2x plus 2y. Okay? And now, the reason I didn't just subtract xy on both sides is because now I can use these to our advantage with the extra x squared instead of just having an extra minus xy with nothing to do with it. So now I can group this into x squared minus 2xy plus y squared. I'll just put that in parentheses so it's easier to see. And then I have plus another x squared, and then if I move this over on this side, I have minus 2x, and then again plus will be y squared minus 2y. And now it's all going to be equal to 0. So we can factor this and we can get x minus y quantity squared. And then if we add one over here and add one over here, we can factor this into x minus 1 squared plus y minus 1 squared. Since we added 2 on both sides, we're going to add 2 on the other side. Or since we added 2 on the left side, we're going to add 2 on the right side. Now, from here, it's important to note that x minus 1 squared, or quantity squared, has to be less than or equal to 2. That means that x can only be the value 0, because that would give 1 because that would give 0, or 2. Because if x was 3, then you'd have 2 squared, which is greater than 2. So these are the only values of x. It's going to be the same case for y. Again, y minus 1 quantity squared is going to have to be less than or equal to 2. So that all of this together is going to be equal to 2. That means that y has to be between 0, 1, and either 0, 1, and 2. Okay? So now we just plug in where x equals 0, y equals 0, x equals 0, y equals 1, x equals 0, y equals 2, and then these, and then 2, 1, 2, 2, into this equation above. And we'll see that, I'm just not going to go through all this with you guys. It's just like extra work that doesn't need to be shown. We'll get the answer 0, 1, 1, 0, 1, 2, 2, 1, 2, 2. It's important to know how these are symmetrical. And then we also have to include the case where x plus y equals 0, in which case we're going to have these options also, or just that one option. K minus k where k is some integer. Okay, and those are all of our solutions. So this right here is the answer. Thank you very much for watching. Goodbye.